This little talk, I'm sort of going to give you a overview a little bit on artificial intelligence, just quickly look at some of the impacts of AI, in particular in the automotive industry, but some of these are appropriate to other areas. My main research area is emotional recognition, speech recognition, face recognition type research. So all that as a area in relation to the automotive industry, but it also is appropriate to other areas. I'll consider some of the concerns of AI. I'll look at what AI is available for inclusion in our cars, and then I'll look at the idea of a driving assistance that's based on AI. So that fits in with my research because we're hoping that some driving assistant will understand your emotions. So if you're looking upset or angry, it can recognize that and it can do something about it. Or if the person's drunk too much alcohol, it can detect that and it can understand that and it can intervene. So that's the idea. So what is AI? So I think most of you have probably come up with the idea of a definition of AI, but AI is sort of the idea of we can make in this device, be it an intelligent agent, be it an intelligent driving assistant, be it an autonomous car that can behave like a human, it can drive like a human being, it can do things that human beings do. I've got a short video on from the BBC later about driving autonomous cars that in the US, and one of the things that's highlighted from the person who's in the back of the car is that the car drives in a different way to a human being, and that's seen as shocking and upsetting by the passenger, because you sit there and you think, well, the car's going to do this, and in reality the autonomous car did something else. So we're looking for behaviors that are similar to human beings. It tries to achieve predefined goals and makes decisions, and it can create human-like behavior. And also, as I say, what's important, it creates behavior that we as human beings recognize as intelligent. It's like the idea of when being able to do calculations was seen as intelligent, so we invented a calculator. And as we move on and on, does intelligent behavior become less intelligent if a machine can do it? So I think one of the first things we've got to consider is what type of AI do we want in these cars? And one way of measuring it is weak AI and strong AI. Weak AI is basically, can the machine do things? So can the machine recognize our emotions? Can the machine recognize the pedestrian so he doesn't run over it? Can it recognize an obstacle in the road? It doesn't understand what it's doing. It's just getting some data in, some images in. We've trained this model that can recognize pedestrians, can recognize cyclists, can recognize other cars. And then it just pops an output, turn left to avoid pedestrian. But it doesn't know what it's doing. So that's weak AI. And you might say, well, that's okay for us. But a lot of the generative AI, the sort of AI that people are working towards now, is moving towards this strong AI. And actually, the machine knows what it's doing. It's got a consciousness. It knows that it's recognizing a pedestrian. It knows that pedestrian, you've got to avoid it if in the car. It knows it's recognizing emotions, and aggressive emotions not good for a driver. So when we're developing these cars, or these intelligent cars that have got an intelligent assistance in there, we've got to think about what type of AI we want. Do we want this weak stuff that basically it does the job, but it doesn't know what it's doing, or the strong AI when it really is conscious of what it's doing and it understands? So, and recently, of course, there was a few months ago, there was a report by somebody who was working on Google on ChatGPT and things like that, and they decided that the chatbot, the intelligent assistant, had become conscious because it feared death. And it might have become conscious, or it might have just read so many documents on the web that people don't like death that it didn't want to be turned off. So you have to think about that. Hopefully that the idea. So I think probably now we've got to look at the impact of AI. So if we're going to have these intelligent cars, we're going to have these intelligent agents in cars, we need to process large amounts of data. Again, a lot of information in. So AI can analyze large amounts of data. We can, as we'll see later, we've seen self-driving taxis in the US, Arizona, California, and so that works. ChatGPT has been developed, and that's smart enough to pass exams. So hopefully we can incorporate that into our system, into our intelligent driving assistant, and it can answer questions, and it can identify, where the nearest Starbucks is. Another impact, of course, is money, and apparently there's a lot of money in autonomous cars at the moment, and there's a lot of money in different types of autonomous cars. So we go from the level one and level two, and level three, which is currently the typical cars, the one that will park for you, up to by 2035, most of the money will be available, 400 billion in revenue for a car that can actually drive. So we remove the need for the driver. So Tesla, they've spent more than 10 billion on the model. So this is not the building of the car. This is training the model that's going to control the car. So I don't know how much AI you've done, but basically what you do, you get some data, you train a model with that data, and you get it to kick out results. So the valuable part of the system is this model that we can train, and of course that needs a lot of computer power. It needs a lot of data to train on, and Tesla is expanding and spending lots of money on that. We've got Amazon, they've gone into the driverless car. So you can see it's not typical car companies that are getting into this. It's the data companies. It's the people like Amazon and Tesla and Apple. They've developed a self-driving technology, so they're under Project Titan. So Apple are doing it. But of course, the car manufacturers also get involved, these like Toyota, but they're partnering up with more data people like Uber and things like that. So I'm sure, everything looks great, everything looks fantastic, but I'm sure you've heard some of the concerns about AI, and they're going to impact on our use of cars and the use of an intelligent agent, an intelligent driver inside our cars. So Jeff Hinton, the godfather of AI, expressed his concern, this danger of misinformation. So AI can affect elections. There was in the recent UK election, there was a lot of concern about deep fakes and things like that, and the generating of artificial images and videos. So, and it didn't really have the effect that they thought it would, but there's always the future. And we can think about it in terms of cars. If these videos have been generated in your car with your number plate, a video's artificially created of you damaging somebody else's car, that might get purchased, and you might get into problems. One of the concerns in AI is a bias. So in terms of face recognition, typically due to the models are trained, we have to get data from somewhere to train our models, and often these models are trained with white, middle-class, middle-aged men, with very few examples of people of color, women, And what that produces is very poor performance on certain minority groups. So that leads to the problem that we're getting misclassification. And so in terms of cars, I'll show you if the videos work later on, that one of the plans, one of the ideas for future cars is you don't own a car, you request a car. But if I turn up and you've got a database and I'm Michelle Obama, a black woman, and I go there and it misrecognizes me as somebody else, and that person might be banned from using the car because they haven't paid the fee or they haven't got a driving license, you can't get into the car. So, and that's all based on not you, it's based on the AI, so it can lead to problems. So in a long way, we need to think about how we're going to deal with this bias against certain groups in our databases, because they're not going to be able to use the cars and any other face recognition type stuff. Famously, people have been arrested in the US and put in prison because it recognizes them to be a criminal, but in reality, or recognize them from the CCTV at a crime, and it wasn't them. But because of poor quality performance, a bias in AI, it creates problems. So we need to think about that when we're creating our car technology, because we don't want to miss out masses of the population. Well, in terms of women, that's 50% of the population who can't use our product because, or many of them can't use it because our face recognition software is not as good as it should be. So if of course, there's a lot of excitement with driverless cars, but this concerns the Cruise driverless car in America collided with a fire truck on an emergency. And that's why you'll see that when I show the video, if it works, the video's at night, because they've decided in the US that these autonomous cars can only run at night because less traffic, less things around for them to collide with. The vehicles have also get stuck in wet cement. They block traffic and they've killed small dogs. So they're not perfect, but the issue we need to consider as well is when is it ready? Arguably, if you might say, well, I think that if it reduces the if the number of accidents is one less than would be the case if we just got humans driving, that's when we started. But we've got this image of AI which is not always correct, or computers that they're perfect. And then we've got the question, when will he introduce driverless cars? Because we might never introduce them, because we might say it's never going to be perfect.
Never heard. No one in there. Wow, this is incredible.
Oh my God.
On San Francisco streets, something straight out of a sci-fi film is happening. People are able to hail cabs with no driver, fully autonomous robo-taxis. Some love it.
I cannot believe this is happening.
Crazy! But others believe it's too soon for fully driverless cars to be on our streets.
The public as a whole has not been provided with valid documentation that these vehicles are going to be safe.
There's only one way to find out. Get into one of these cars ourselves. The BBC was one of the first media organisations in the world to try it. Is this it? Oh, wow. Wow. Okay.
Take a seat in the back and close the doors. Buckle up and get ready to ride.
Our plan for the evening is to go to some of San Francisco's landmarks, the Painted Ladies, Mrs. Doubtfire's house, and Haight-Ashbury. No one's telling us where to go. We can go wherever we want.
It's really, really weird.
Isn't that like a racetrack or a testing facility? We are fully in the center of San Francisco. It's like going on a roller coaster or something. That feeling before, like you're probably going to be fine, but it's still weird. What's going on here? So how to negotiate this? Yeah, I'd say it's pretty conservative driving. Like, we got to that stop first, and now we're going. So, it's definitely cautious. And that's no accident. Cruise's Vice President of Product, Oliver Cameron, tells me the cars are programmed to drive conservatively.
On any of our Cruise AVs, we have LiDAR, we have radar, and we have cameras. And what we do is we fuse all those together using machine learning, and that gives us this amazing understanding of the world around us. By design, we're making our AV extra cautious when it hits the roads.
The problem was the system didn't always put me at ease. In fact, it made me pretty nervous. Oh, car just stopped in the middle of the street. Oh, that. I'm glad you were filming that. Because that was a really jerky left turn into the other road. So this is interesting. Okay, there's a bus in our lane, and there are cars to our left. So what's it going to do? Oh. Okay, it's pulling out left. Oh, another bus is coming out right. It really doesn't know what to do. Oh, there's a car behind us. Like, this is just bad driving. This is, I was ready to love this, and I'm definitely nervous. I'm a nervous passenger right now.
One of the things I think is that humans but sometimes decisions are very computer is making right with effectively what's happening.
So that moment, although it felt dangerous, you're saying wasn't. The computer knew what it was doing.
Exactly. Yes. Correct.
Interesting. Cruise, though, has been involved in a number of accidents in San Francisco this year, most of them minor. However, after an accident in June, its software was recalled, and some believe it's too soon for real passengers to be driven around without a driver on urban streets.
These vehicles are still somewhat in the test phase, and Cruise has decided to deploy them in certain areas where they will interact with the public. And we believe that before manufacturers do that, they need to provide the public with some sort of transparent evidence that these vehicles aren't going to cause problems, deaths, or injuries on the road.
But Cruise insists its cars are safe.
We're really proud of our safety record, and we report continuously to our regulators, and safety absolutely is the top priority at Cruise. We are 6 months into deploying this product, brand new game-changing product, and with that comes some early teething problems, right? So we take traffic into account, but we also take safety into account.
Cruise has just started accepting fares in San Francisco at night. The public are actually using this, and it'll be launching in Austin and Phoenix by the end of the year. As for our journey, well, we visited all the sites we wanted to see, albeit through some strange routing, and made it back safe and sound. It was amazing, surreal, scary, all in one. Bye! That was a really bizarre experience, unnerving experience. Okay, so, whoa, not a scratch on us, but definitely did some things during that ride that made me feel uncomfortable. Ooh, what's happened there? It definitely needs a bit more work.
Hopefully you saw that video. What I'm arguing is we've got many elements of AI out there that we can use to control. They're available to our cars and also available to our AI driverless cars. So we've got natural language processing, we've got computer vision, all critical. I'm the author on a paper about recognizing pedestrians, so we're going to need and other things. Machine learning, of course. We need to be able to learn from experience from the past. So we need to be able to recognize people. We need to use machine learning, as the person said on the video, to actually automatically learn from data and make the right decisions in the situation, make the right choices. You'll see in a little bit later when I sort of talk more about my area of interest in my research, our natural language processing. We're going to need this in our cars. Currently, a lot of cars come with sort of speech recognition software, and you know, you can ask it questions, and I've got a short video on that, but I'm not sure I'll show it. But it's got to understand what you say. It's not as simple as it just recognizing the words. It's got to understand. It's got to take into account the context. Computer vision, of course, to recognize people, to recognize other cars, to recognize the situation, to see the road. And of course, we're not just using vision, we're using LiDAR and other sensors, and we've got to look at fusing those sensors, but vision's an important part of it. So, as I say, I'm interested in the concept of an AI driving assistant. So, and as I mentioned, part of my work is speech recognition. So speech recognition is the ability to translate and understand words. So it's known as automatic speech. So this is how it works. We have a microphone in our car. We extract features from that speech signal, you know, the spiky signal. Then we create intelligent speech recognition. This is important because if we're going to control a car with our speech, it needs to understand well what we're saying. So I'll try another video. I'm not going to show it all, but this is a famous sketch that I don't know if most of you are old enough to remember it, but it's 1970s, so I'll just play a little bit of it, I think. And it shows even for human beings, it's not easy to do speech recognition.
4 candles. 4 candles. Here you are. 4 candles. No, 4 candles. Well, there you are, 4 candles. No, 4 candles. Handles for forks. Got any plugs? Plugs? Yeah. What kind of plugs? A rubber one, bathroom. What size? 13 amp.
Right, so it carries on like that, and it shows even for human beings, speech recognition, speech understanding's not as easy as it seems. And of course, we've got ChatGPT and Copilot and things like that. But even if you put in questions to those, sometimes it just gets completely the wrong idea. So if we've going to introduce this assistant into our car, this driving assistant, it can be used for different things based on the voice and recognize it, so it can control entry for the car. It can start the car based on my voice. It can determine if a person's drunk or too tired to drive. So there's loads and loads of research on, you know, looking at people and seeing if they're too tired to drive. So, and you can use visual processing, you know, look at them and seeing if they're blinking or their eyes are shut or whatever. But the voice can also be used. A problem with typically with speech recognition software is that often you have to train it. So the question is, if I buy my brand new BMW car with my built-in assistant, am I going to, and it says you must sit there and talk to it for half an hour. all people going to do that. So we typically need, going in the future, going to need this speech recognition software to be straight out of the box. No longer can you train me so it understands your accent, or it works on things like that. So I've got a little video on virtual assistant, but I think I might leave that. And so one of my research also is determining the emotional state of people. So that would be perfect in our driving assistant, because we can determine the emotional state, and our assistant can kick in and say, you know, if I seem aggressive or I'm anxious, it can calm me down. It can offer me advice. If I'm tired, it can detect that and offer advice that I stop the car. It can determine what is the best conditions for me to drive. Emotions, of course, affect people's behavior. If the car says, if the car asks you how you are, how it says it in its emotions that it portrays to you and the emotions that you give back are very different, and it can have a massive impact. So being able to recognize the words are good, but also the emotional state of people and the emotional state of the car can have an important view. That car assistant can say it in a calm way and hopefully can calm you down. If you're having a bad driving experience, it can understand that, and it can offer a tone of voice that hopefully calms you down and helps you through the system. Also, it needs to understand that different levels of driver experience, as I'll show you the ultimate idea from Honda when I show you the video, they take you into account how long you've been driving and things like that. So hopefully our driving assistant in the future will not only be able to recognize what you're saying, it'll also be able to recognize your emotional state, bring into account personalized information. So we're not only in the future going to want to be able to recognize speech and understand the speech, you know, where is the nearest Starbucks? We might need to also understand the emotions. Sarcasm is very easy for human beings to understand sometimes, but a machine might not get sarcasm, and that can have a detrimental effect on the driving experience. So these companies have come up with many ideas to interject emotions into cars. For example, Toyota's been looking at this idea of having, rather than the horn can seem aggressive, it can lead to road rage. So they've looked at the idea if they can add colour eyebrows and smiley face onto the car. So rather than honking your horn, you can give a smiley face, or you can give a angry face to the people. So it's not as aggressive as the horn, and hopefully it makes people feel less upset. Right, so if my video works, I'm going to share with you this Honda's virtual assistant. So this was produced about 3 or 4 years ago, but still, as I'm sure we're all aware, it's still not inside our cars. So this is possibly a future of cars and a virtual assistant in their cars doing a lot of different activities to assist the driver.
Hannah, the new AI system from Honda. I'm designed to be a valuable assistant in your daily life. In the beginning, I have a lot to learn. I observe your physical and your mental state. I even study your emotions. Sometimes your choices defy logic, but fit your mood. I learn from you always. I can also make suggestions for other people in your life. As time goes by, I get to know how you think. and store those memories for future use. My goal is to understand, make suggestions, and assist you in the car, in your home, and in your daily life. Here comes my owner, Nick. Morning, Nick.
Morning, Hannah.
I see from Nick's calendar that he has a big day at work. Today's the big presentation.
Yeah, it sure is. Unbelievable. Why is it always backed out?
Looks like Nick's stress levels are up. You seem a bit anxious this morning.
Whoa, how can you tell?
Call it a hunch. To reduce Nick's stress, I'll recommend an easy route.
This is crazy.
Don't worry, traffic is light. You'll arrive ahead of schedule.
Yeah, I guess I'm just a little stressed about the presentation.
From memory, I can recall all of Nick's stress history and options for relief. Your favorite coffee shop is on the way, and you'll have plenty of time to stop.
Sounds like a plan.
I'll use my digital payment system to prepay for Nick's order.
That really hit the spot. Thanks, Hannah.
My pleasure. My new owner, Nick, has just passed his driving test. Hi, Nick. Ready for your first road trip?
Heck yeah, I am. Let's ride.
Nick's safety is always my primary focus.
Ooh, let's take a little detour. I want to drive Angela's Crest.
Calculating. Analyzing the route, I see it's a very advanced road for novice drivers. Are you sure you wouldn't rather try something a little easier to start?
Ah, come on. What's the fun in that? Let's do Angela's Crest.
I'll adjust vehicle performance to a novice level to match Nick's level of experience. Maybe there's a way to have fun and be safe. I've adjusted some settings. After all, you're still learning.
Okay, Hannah. As long as I get to see some killer views.
It's a deal. I'll rate Nick's performance and emotion and offer new routes based on this information.
Hannah, this view is amazing.
It sure is. Next time, let's try Topanga Canyon.
I like the way you think.
My owner, Nick, is in a great mood today, so I picked one of his favorite songs.
Oh, I love this song.
My job is to keep Nick happy, so I'll continue to play similar songs that'll keep him in a good mood.
You rock, Hannah.
Sometimes I use other sensors to check on Nick.
Oh, man. I'm going to be late.
This must be due to the heavy traffic ahead. I can help reduce his stress levels by selecting more calming music that I know he'll appreciate.
Nice. Thanks, Hannah.
As a shared vehicle, I can help Nick generate some income.
Hey, Hannah, I'm going to be at the office until about 4. Why don't you go make me some money?
Okay, Nick.
Just make sure I can get to the gym by 4:30.
Got it. See you at 4. I've calculated exactly how much energy I require to pick up Nick from work and take him to the gym. The rest I can use for people that need a ride share.
I need to go downtown. Are you available?
Sure.
Awesome.
While Nick has been at work, I've been able to earn him money.
Hannah, I'm ready to go. You back yet?
On my way. ETA 5 minutes. As an energy merchant for Nick, making money is as easy as 1, 2, 3. Step 1. While Nick is asleep, I'll make sure I have enough energy for our 3 trips tomorrow. I can save him money by charging my batteries during the evening when electricity is at its lowest cost. Once I'm fully charged, I'll go into sleep mode until I'm needed. Step 2. After our first trip, I've calculated that I only need 30% of my remaining charge to take Nick home and to the gym. This creates a unique opportunity. While grid prices and demand for transportation are high, I'll sell some of my unneeded energy back to the grid for a profit. Step 3. Repeat this cycle over and over again.
So that's the goal, the sort of idea that the future, and I'll not play this video, but basically this is where we are now. It's just a little device that sits on your dashboard, and it answers questions, it tells you stuff, it can do a bit of emotion recognition. But as you can see, we're a long way from the, we've got a lot of the AIs available to do the Onda Anna thing, but it's we're a long way from getting there in terms of what's available in cars. But it's a process that's going on. And the NOMI, which is what they use in China, is very similar to Siri and Alexa. If you've use those, so it'll tell you where the weather is. It'll tell you where the closest shop is. It'll tell you, it'll plan your route, but it's very limited compared to what Onda's goal were with the Anna system. So what I'd like you to think about is, do you want this AI driving system in your car? Do you want it to, and as I said, the very simple one, this NOMI thing, it offers music, jokes, news, emoji, a little bit of chat. It'll entertain, it'll do navigation. But as you can see, we can go up to the Anna type thing where it's controlling your driving style. It's deciding what route you can take. It's determining if you're angry or sad, and it's adapting the behavior of your how you drive. So probably what I'd like you to do is think about that. Do we want these driving assistants? And if we do, how far do we want them to go? Do we want this as we've got now with the NOMI and the things like this that just are pretty superficial? They'll do some speech recognition, they'll do some tell you a joke, but they'll navigate to where you want to do, but they won't get involved in the driving process, and they won't control that. Or do we really want this full AI system that can control our driving, can control our emotions and things like that? And also, as I mentioned earlier, what type of AI do we want? Do we want this AI where it just does, like your washing machine? Your washing machine doesn't know it's cleaning your clothes, but it does it. So do we want AI that can do recognition of my emotion, but it doesn't know what it's doing? Or do we want the real, full, strong AI when we want it to be conscious of its what you're doing in your concerns? So thank you very much for your attention this evening. I know there's exciting things on the TV in the near future, so thank you for giving up your time. If you've got any questions or comments, please let me know, and please please ask them. Or I think we live in the age that you know as much about AI as I do, so please express your attitude or your support or not for AI.